Hello and good afternoon or good morning, depending on where everybody is today. Welcome to what we're billing as a very special event. We're really excited about the introduction of the new Terragraph technology, which you're going to hear about today. In my own opinion, this is the biggest step change in our industry, probably for 20 years. And, Wi-Fi has been out for 25 years now. It's the 25th anniversary this year. So I have very, very high expectations for what this technology is going to bring to the market. And I'm really, really pleased to be at the forefront of that, giving you first-hand insight into what is forthcoming with this exciting new technology. So welcome. And first of all, I'd like to introduce our very, very distinguished panel and just invite everybody just to spend a few seconds just saying hi and to introduce your position. I'll start with you, Boris, if possible, please.
Yeah, sure. Thank you for the opportunity. Glad to be here at this panel. My name is Boris Maisel. I'm based out of San Jose, California, work in Ciclu in the role of AVP of Strategic Accounts, primarily responsible for business development and developing business with Ciclu's strategic customer and one carriers.
Thanks, Boris. Anthony?
Yeah, hello, I'm Anthony Holmes. I'm based in the UK, down in Ashburton, and I'm head of the engineering department, vice president of engineering, and looking after research development and now millimeter wave and 60 gigs part of that portfolio.
Thanks, Anthony. Very welcome. Adi?
Hi, good afternoon, everyone. My name is Adi Nativ, and I'm a vice president of global business development from Radwin. I am based in the US, New York City area. Among others, I oversee the Terragraph program at Radwin. Been working on it for the past few years, working now and moving from development to marketing it, bringing it to the market. Very happy to be here.
Thanks, Adi. And Mark?
Hi, good morning or good afternoon, depending where you are. I'm Mark Kelly. I work on the partnerships team at Facebook, principally focused on Terragraph and hoping to spread the ecosystem far and wide as we launch commercial products this later in the year.
Thank you. Thanks, Mark. And Gino, you're not a vendor, but you've actually been using this kit. So welcome and please introduce yourself.
Thank you, David. My name is Gino Valorini. I'm CEO and founder of Aeronet Wireless Broadband. We're a hybrid service provider here in Puerto Rico. We use fiber and fixed wireless technologies to deliver our services. Very happy to be here.
Thank you. Thanks for joining us. And last and probably least, I'm so sorry to put it in such a way, Niraj, if you wouldn't mind just saying hi.
Hello, everyone. Hi. My name is Niraj. I'm the product manager for Terragraph, and I manage inbound and outbound aspects of Terragraph from a Facebook standpoint.
Thank you very much, Niraj, and thank you to everybody for joining us. And I appreciate that for some it's quite early in the morning. I think you're all somewhere towards the United States, in some cases in California and some slightly more east. So thank you very much for taking the time to spend with us today. So we're going to go through a format today, which is going to be led by Mark initially from Facebook to give us a presentation on the Terragraph ecosystem, where it's come from and where it's heading. We're then going to go into some discussion and questions and answers, which I'll be hosting. And we're planning to create some time at the end as well for questions from the audience. So if anybody does have any questions that they would like to raise, please can you use the Q&A feature at the bottom of the screen. So if you wiggle your mouse around, you should see a little panel come up. And one of those items there is Q&A. So if you have any questions, please type them in there and we'll do our best to respond to those either within this session, or if not, we'll take a follow-up and we'll pass any answers back out as well. This session is recorded and we will be publishing the recording in the coming days, hopefully by Monday or Tuesday of next week. So welcome and thank you to everybody. To begin with, I'd like to hand over to Mark from Facebook to take us through an introduction to Terragraph.
Thanks very much, David, and thanks everyone for participating this morning or this afternoon. I'm going to go through the Terragraph technology, really the evolution of the technology, why we're doing this at Facebook, what we feel how it's going to benefit the industry widely and globally, and where we're at today, and then hand it back to David to do some Q&A with the OEM partners and service providers that we have on the phone today and take questions. So just to answer kind of a quick question we get fairly commonly at Facebook is really, why are you doing this? Well, what is it that you hope to accomplish with Terragraph? And is this really an area Facebook's active in? And just to give you a bit of background, as Facebook grew as an application, a set of applications, we realized rather early on that a lot of the performance of the applications that are being used widely, not just ours, but everyone's, really dependent upon the network itself. And we got pretty heavily involved early on in some of our own data centers and what we could contribute to data center technology and how we design something to deliver, store, and provide a wonderful user experience for our users. And that involved early on, when things were more desktop-based, getting involved in DCs, and we did a fair amount of work there, and it contributed to that openly to the ecosystem. When the world really went fully mobile, and primarily mobile anyway, with the applications that we promote and have as our core business, we made the same observations, and really a lot of these observations came from our partners, service providers, and others in the industry that were serving up applications. And in fact, this should be no surprise to anyone who's watching the webinar this morning. New applications require higher speeds. Good applications, great user experience requires high fidelity broadband. And we've all seen data doubling, virtually was every year, now it's every couple to 2-3 years. So that the cumulative annual growth rate's pretty high, and the number of connected devices by next year could exceed 29 billion. So this should be no shock to anyone on the phone. Data consumption increasing rather dramatically and without any signs of slowing. And what that has done is, even in places where there's a lot of good network available, even new deployments of 4G globally in some large areas, what we've also observed has been that some of the speeds actually start to decrease. The success really breeds a lot of consumption. And what that's had is a rather powerful effect on networks. And this is, again, nothing new, and particularly during the COVID times, the demand for broadband hasn't ever been higher. And the time it takes to deliver high-speed broadband wirelessly is not just the wireless component, as you know, but the transport component as well. And so just laying fiber, getting permits, right-of-way, zoning, drilling, in an area of fiber connecting, these are fairly high time consumption events and quite costly as well. So there's a couple big detriments that we saw to getting high-speed broadband out in the marketplace quickly. Now, Facebook is not a service provider, and we're not an OEM. But we did believe we could contribute, and do believe we're contributing to the wider ecosystem through a number of activities that we have in our Facebook connectivity group and the telecom infra project at Facebook. And one of these biggest activities that we've had for about 5 years now has been Terragraph. The intention there, and originally, was solving the urban bandwidth challenge. What we saw early on was it's not just an urban solution, it's a suburban solution, a rural cluster solution. And we've seen a lot of interest from all of those areas. And last year, as the technologies come to fruition, is about to enter the market commercially. So it sort of raises the question, what's our role in Terragraph, short-term and long-term? Really, what have we been doing, and how will we continue to contribute to the ecosystem? First and foremost, we really help create this technology, not create it, really assemble it. So we have our own program at Facebook to the level we developed a proof of concept, which we have done large scale and small cell trials around the world. I'm going to tell you a bit about before we hand it over. We've helped actually develop a lot of the software that's going into the system ourselves. We've done a lot of the interoperability testing. We've helped enable a lot of the OEMs that you are going to be hearing from in a few minutes with technology we developed and freely share with the ecosystem. Moreover, spectrum as well is pretty critical to wireless, as you know. And what we have done here is contributed fairly actively to the 802.11ay standard. As you probably know, the 802.11ad standard, also known as WiGig, has 2 gigahertz channels and covers a fairly wide range, up to 14 gigahertz, with a full band available. Now, that's not available outdoors everywhere in the world. In fact, when we first started on Terragraph, it was only available in a few places. Over time, as regulators have looked at this band and looked at it for outdoor use, not just early indoor use, what we've seen is a lot of adaptation of the regulations for this use case of doing outdoor, limited range, high capacity wireless systems. So we both advocated for spectrum policy around the world, making it really more available to the population in places around the world that haven't had the availability of high-speed broadband. And we have done that at a number of levels, and we will continue to do that. Finally, I mentioned the TIP ecosystem earlier, not just the TIP ecosystem, but with trials and with our technology sharing and some other products and services that we've developed that are really part of deploying and operating a Terragraph network. We're contributing also in the engagement in the full ecosystem. Let me quickly walk you through the technology itself at a high level. The OEMs on the phone will be more than happy to give you a detailed description of every aspect of it. But let's just tell you about what the high points are. First, it is operating in the unlicensed 60 gigahertz band. So that makes it easy to get started right away. And in a lot of the places that you're probably listening to today, it's free and clear to use outdoors. Second, we need a gigabit technology, and Terragraph can deploy 1.9 gigabits a second good put, 5 gigabits a second, 4.5 raw 5 throughput on a single channel. So we meet the gigabit per second bar. With channel bonding, we're going to be able to do 3.5 gigabits a second in each direction of good put through our technology, through Terragraph, the AY technology next year. Moreover, on top of just the radio and link aspects of it, Facebook had also developed a routing technology called OpenR. It's a bit like OSPF. And we've done that in our data centers. We basically took that same layer 3 technology and applied it to the mesh layer. So you have a single pop, maybe a couple pops in a fairly, let's say, a 1, 2, 3 kilometer area. We're able to spread that bandwidth through the area, have resiliency through the mesh in terms of just load management, access routing, and availability. It increases the availability of the network and makes it fairly seamless to expand over a fairly large area. Finally, there's a number of different ways and pieces of technology are available today to spread high-speed broadband. This is low cost and it's fast to market. And so through high speed, fast to market, delivering the mesh layer, we feel we have a good foundation in place for spreading broadband cheaply and quickly, which is really what we saw the industry needing. I mentioned before the 60 gig band. There's an illustration here that basically shows the mass of each channel. There are 4 channels shown there. You really get up to 6 channels with a full 60 gig band going up to 70 gigahertz from 57. So each one of those channels can deliver, obviously, this is an unprecedented amount of spectrum. So you get, as I mentioned, the full 4.5 gigabits per second with MCS 12 on any single channel. So it's high speed. Secondly, OpenR, mentioned that. One of the things, if you look at a layer 2 mesh, there's some limitations on how effectively it can manage traffic and spread it. Some folks have looked at that. In fact, we looked at that initially. With a layer 3 mesh, where every node is essentially a router, you're able to virtually infinitely scale the network over fairly large areas. And that was really why we took the step to do full layer 3 routing with OpenR. Another big change that we made from the WiGig 802.11ad spec was to change the MAC layer. So as you probably know, like Wi-Fi, the MAC layer for WiGig is CSMA, which is great for indoor limited use. But for very high availability, scheduled management of traffic, TDD and TDMA are really a better way to go. And so what we have is a MAC layer with AY, which is a TDD, TDMA MAC. For managing the network, doing a number of other activities, obviously we have a cloud management system that we have developed that allows you to basically manage all your network, have high visibility into the network, see what's happening, see where there's issues with the network, configure, bring up, and so forth remotely. A lot of that is resident in network when we're deploying it, but can be controlled from the cloud. Finally, in order to deploy a network with extremely high value and to do it with a line of sight type of system like Terragraph is, requires some crisp network planning tools. There's a number available on the market today. We have developed one called ANP that we're using with some of our OEMs that's LiDAR based. I'm going to tell you a bit about later. Terragraph use cases. So what was the point in Terragraph, as I mentioned, to bring high-speed broadband into urban, suburban areas, even rural areas. So the use cases we began with were fixed wireless access. So here we're just deploying a network that's composed of essentially two elements. One is a distribution network of radios, either at rooftops or ground level, that's essentially spreading the pop fiber signal throughout your market area wirelessly. And if you look at the illustration here, you see a couple of lampposts that have some nodes on them, and those are Terragraph distribution nodes. And the colored blue is here indicated where we're doing FWA. So here we're simply taking a point-to-multipoint radio, shining it at the sign of a building. There happens to be a customer there, whereas the one shown. We can go up to 16 customers on the side of a building in the point-to-multipoint distribution of a single Terragraph node. Fixed wireless access then with nodes that typically are in the 150 to 200 meter range, perhaps 100, really depends on the topography, location of the poles or rooftops. With parabolic dishes, we can stretch that out to around 1 kilometer. And you'll see and hear a little bit more about that later. But the baseline system that we developed is based on phased arrays, which allows tight beam steering, which is how we can do the point-to-multipoint access on a building. The second use case, mobile backhaul, rather obvious if you have a street level network and you're going to be deploying a licensed spectrum RAN solution on top of that, 3G or 4G or 5G. We'll get to a bit about that later. You can also do backhaul to those mobile radios. Obviously, if you have a neutral host or a type of a city network up and you're doing fixed wireless access, you could also do outdoor Wi-Fi. In fact, we've done that. And a number of our early test cases were widespread outdoor Wi-Fi that we did both near our office in Menlo Park in the city of San Jose. And we've also been working with carrier YTL under their Yes brand in Malaysia. And they have a fairly large outdoor Wi-Fi system that they demonstrated last year and earlier this year as well, still up today, being converted. We'll tell you a bit about that later. And finally, obviously, a smart city is a sort of a natural application for such a technology. And we see a lot of value there as well. Quickly on FWA, if you look on the left side of the illustration here, you can see some of our proof of concept radios. Each one of those is one node of a 4-sector cell site. The cell site here is the pole with the 4 radios on it. And if you look at the illustration that shows the photograph, you see the speeds we're getting there and where that was, which was the YTL network I mentioned just a moment ago in Malaysia. So here the download speed being measured at the access layer is 1.3 gigabits a second and upload is 1.7. Just a moment on the access layer. The access layer is typically Wi-Fi. It can also be a wired connection through the rooftop of a building, which goes into the units of the business or apartment, like GigaWire or GFast and so forth. And in fact, a couple of the deployments that you'll see are using that type of access technology. In this case, I believe we're measuring just broadband Wi-Fi out on the street. So gigabit speeds on the left, an example of what our proof of concept prototypes look like. On the right side are really one of the key aspects of any wireless technology, and Terragraph in particular, is how quickly it can be deployed as a transport layer vis-a-vis fiber. Of course, we have to get permits too, but the task of trenching in particular can be quite time consuming. And even right away between the street access and where your customers are can also be quite time consuming. So here, by shooting over wirelessly, and using rooftops, you can deploy the network quite quickly, and we're going to give you a couple examples of that as well. I mentioned network planning tools, and I'll just start on the right side. So as you see this, what you're looking at is essentially a point cloud LiDAR image, some data collected in Berlin. We were doing automatic pole collection, tree identification, and network planning. Essentially what we have put together is a tool which collects such data, LiDAR based on street level collection, rooftop collection, shape files, other DSM data, in order to do a point-to-point line of sight automatic network plan. It creates every permutation from any 2 line of sight points that are in the range of the radio, eliminates those links that have obstructions from trees or buildings and so forth, and comes up with several options. From those options, then you can calculate the total amount of CapEx needed to deploy the network and do your own comparisons prior to even breaking ground or looking at this is a good solution for you in the area that you're looking at Terragraph for your services. On the left side is some calculations on TCO based upon some network planning outputs. As expected, generally it's significantly cheaper and faster to deploy than fiber. Just compared to fiber at a high level, the CapEx laying fiber can be quite prohibitive up front. It doesn't have as much OpEx downstream. It's essentially just buried glass, as you know. It's just really the energy and some of the maintenance levels. Terragraph, much less CapEx to deploy. There's some power consumption at the poles where the radios are. And generally that in pole rentals, what's driving your OpEx in the business model. In order to deploy the network, manage the network, control and configure nodes in the network, we have our own network management system. It's cloud-based. We've used that in all our trials. It too is available, but more than likely, depending on who you are listening now, you may want to use this network management system available, or whatever's available through your vendor, your OEM. But all the hooks are in the native system itself to be able to collect all the data you need to see what the performance is, any events and alarms and so forth in your network. The picture you're looking at on the right there is just a small part of our network in San Jose. The green nodes represent Terragraph distribution nodes that are out there on the street. They can connect, and in this particular deployment, those are providing Wi-Fi access. The red nodes are nodes that simply haven't been brought up yet or being maintained. This is a test network, not a commercial network. And it's what we use to really hone the network and develop a lot of the systems and check the network planning accuracy and do a lot of tests. That went on over a full year in 2017. Just a brief comparison on some different transport technologies that are being used to deliver broadband. And if we'll just sort of go from left to right, as I mentioned before, trenched types of deployments, fiber, coaxial cable, and so forth, have a couple of elements to them. It's kind of a lot of money up front generally to deploy it, and the cost per home pass can be, depending on how you're doing it, or micro-trenching, the distance between homes and so on and so forth, different topographies, can quite easily exceed $500–600 US. It's providing unprecedented capacity with fiber, and fiber is part of a Terragraph network as well, but it can be quite time consuming. The same goes for a number of other type of trenched and wire technologies. If you look at 5G FWA, it too can deliver the same kind of gigabit speeds, generally much more expensive than any licensed spectrum. So what the value of Terragraph in a rooftop deployment in particular is extremely low cost per home pass and fairly rapid time to deploy the network. And if you look at the three elements here, here's three different networks that we've designed. One of them you're going to hear a little bit more about, which is in the center. Going, let's say, from left to right, left is just rooftops on fairly large business buildings in a downtown metropolitan area, that's in Sao Paulo, Brazil. With a radio and a rooftop and a fair number of units available in the building, the cost to cover anyone just past one of those office buildings is pretty small, and it's really leads down to $50 per office in a high rise where you have a radio on the rooftop. And then the distribution into the office itself is fairly thrifty, so it comes out to be quite cheap. With a rooftop model in the middle, and I'm going to let Gino talk a little bit more of that. That's his network. That's using rooftops. Again, fairly low cost per home pass there, a little bit more than in the model on the left, but still quite attractive from a TCO standpoint. I'm not going to say any more about that. I'll let Gino describe it. Finally, on the right is a lamppost-based street level design. And in this design, you can see this is an output of a network planning process that we have. And you can see green lines that are going between distribution nodes. And if you can make them out, there's some orange lines that are showing links going to customer subscriber homes on the right. So going from left to right tends to increase in cost. Obviously, if you look at the right, there's a lot more poles in just generally, just as a visual quick look, as there are rooftops in the middle. So it gets more expensive the more distribution nodes you have out, but then you have the ability to connect everybody at the ground level if that's your desire. Quickly, Penang, I mentioned before, that's shown to the left, and you can see the considerably more nodes there from the network management system output. That's a network of several hundred nodes serving hundreds of fixed wireless access customers. It's up and operating today and will be converted to a commercial network later this year. Early on, we did some trials in Hungary with Deutsche Telekom subsidiary there, Magyar Telekom. We did 2 cities there. They were fairly rural cities, and we interconnected them with street poles. power utility poles. That was quite a game changer for the folks in that town, and that was successful. And really going back in time here several years ago when we deployed a widespread network in San Jose. I want to wrap up talking about our ecosystem partners. I'm actually going to start with the right. The core technology on the AY chipset is being developed by Qualcomm, and it's going into our OEM partners here today. And so we'll jump from the right over to the left side. I won't go over a list. You can read that. You're going to hear from several of those OEMs this morning. In the center are some locations where we have done outdoor trials with operators around the world, in Brazil, in Indonesia, in North America. So that's where we've done. There's actually quite a few more that we've done that aren't shown there. The idea is we've been demonstrating this for the last year and a half, and it's ready. So I would like now to turn it back over to David and the panelists and go ahead with the questions.
That's great. Thank you very much, Mark. I mean, it's amazing. So much work has gone on. This is not kind of fresh out of the lab today. This has been field tested, and it's good to see. There's some maturity before it arrives in the market. We've seen products in the past come out which don't look like they've been fit for purpose on day one. So this is very reassuring. I'd like to go through a few questions with you as panelists. One point was raised earlier on, which I'd just like to pick up on, which was raised by Steve Kaminsky. Just a correction, really, about unlicensed or license exempt. So it's the good thing about license exempt is you don't have to pay for it. So I think that was the point that was raised there. I'd like to start with Gino, if I may, as the operator in the room that's tried it. Just really, I know that you've worked with fixed wireless products for a while. You work with fiber as well. What is it that made you want to invest in a 60 gigahertz based system?
Oh, thank you, David, and good morning and good afternoon to everybody here in the forum. We've been a fixed wireless operator for quite a while, since 2001. So our main technology and our main knowledge base is around fixed wireless. We entered fiber just recently, about 5 years ago, as a complement to our network. And but the matter of the fact is that we are a true believer of fixed wireless technology, and has been for a lot of time. And we have been always seeking a way to provide our end users with faster speed. There's a lot of companies locally that compete on a day-to-day basis. So since about 6 years ago, I think, or 2016, so I believe, I heard about Facebook development of Terragraph technology, and I quickly became interested in it, and I started to research on it and how can we get this to trial. So really early on, we were very interested in the technology, and we were very excited to be able to trial it last year when we were able to reach an agreement with Facebook and trial the technology here in Puerto Rico.
Okay, that's cool. We'll come back onto that in a little while, because I think it'd be interesting. Many of our audience are in your position. They are wireless operators, and it's interesting to see what the motivation is and what the outcome was. So we'll come back to that. I'm interested, really. We've got a lot of vendor support on day one, which is great. And Radwin, Ciclu, Cambium, you're already well-established providers of high-quality fixed wireless access technology on a global scale. This opens up I presume, a slightly different market. So starting with you, Boris, what do you think is the market outlook? What is the opportunity for you, Ciclu, to be involved in Terragraph?
Okay, so let's start with the broadband opportunity, because I think that this is the opportunity that our familiar with. Let's look at the UK broadband report and the Ofcom Connected Nation. There are 12 to 13% of all the connections in UK are fiber. And this is pretty much the same number for rural, for urban, for businesses, for residential. Now, if you look at the FTTC data, fiber fiber passed data, according to the research, it is 62%. So 62% of homes or locations are passed, and only 12 to 13% of those locations are connected. So this is gap of 50%. This is an immediate opportunity for fixed wireless. Now, if we look at that from a different perspective, it was an INCA survey that was published at the beginning of the year that listed several major concerns of independent service providers. Now, most of those concerns, the top concerns were related to OpenReach, either that competition of OpenReach or the slow deployment of OpenReach to get to the customers. So I think that this technology, millimeter wave fixed wireless, and in particular Terragraph, what helps to turn this threat, if you wish, into an opportunity, because there is a gap definitely between FTTC, and this is what OpenReach BT is doing, and the end user. So this is exactly where small players, WISPs, can come in and bridge this gap and not be afraid of OpenReach overbuilding the deployment, but in fact, providing a hybrid fiber wireless approach and extending this fiber. In other cases, they can be faster to the market and use this technology to get faster access to faster deploy this this technology and the service and get faster to the customers. Another angle is help from the government, and this technology also can unlock some of the funding of the program that probably the audience is familiar with. For example, there is one gigabit broadband voucher scheme that provides £1,500 to home connected or £3,500 to business connected. And this can solve the initial investment and actually make the business case profitable from day one. Cash. So using this technology, the service provider can deploy a gigabit capable service, which is a requirement for this type of program. And with designs that we've done, it is easy to show that home passed can be well below £100 and home connected can be well below £500. And getting this voucher from the government actually makes the business case work and cash flow positive from day one.
Yeah, okay. Thanks very much for that, Boris. I think there's some really good points there. What do you see, Adi, from Radwin? What do you see as the market outlook? Does that reflect that?
Yeah, first of all, I fully agree with Boris on his observation on the market, and especially on the UK market. Maybe just to add, as Boris clearly stated, this is not competing with fiber, it's complementing fiber. Actually, the facts that Boris just mentioned indicate that the growth of fiber penetration is good for Terragraph. It's getting closer to many homes, and it's enabling now to close that gap in an easier way. So to complement on what Boris had said, the opportunity is getting bigger and bigger as long while fiber deployment is increasing. We see the opportunity with homes, with buildings, with businesses. We see them in urban, suburban, and clustered rural, as Mark has indicated. And I think that in principle, this technology coming with the mesh, and we may address it a little bit later, but coming with the mesh capabilities, which is very unique, it's not requiring the fiber pop to be very close to each one of these buildings. The mesh enables you to take a fiber pop and then extend it further into a whole area and not just a specific home. So you don't need to be 100 meters, just to make it clear from what Mark had said. You don't need each location or target location for Terragraph to be 100 meters, 200 meters from the fiber pop. Actually, the Terragraph would go and extend from a fiber pop hundreds of meters, point to point to point, a relay to a relay to a relay, and extend the network to cover a large area. And this is a real unique opportunity that Terragraph brings to the market.
Yeah, thank you. I think we'll see a lot of the word hybrid coming into this a lot over time, but extending the value of fiber, it sounds like a really interesting one. I'd like to turn back to you, Gino, as the user in the room. What are the key use cases that you see for Terragraph, and in your experience so far, what performance are you seeing? What is the customer experience so far?
Yeah, thank you. I would like to briefly describe our trial network, which was using Facebook hardware that was provided to us. We have on the San Juan, capital of Puerto Rico, we have a very historic area that fiber is not available because of historic matters. And we understood that that area was perfect for deploy Terragraph trial because it's a very densely populated area with a lot of businesses, a lot of tourism. So there's a lot of business going on. A lot of people live in that area, but they were not being served with true broadband. They were just having like old copper line DSL with a lot of trolls. So that was the perfect case use for us, and we presented that to Facebook, and they agreed to do the trial. So our network right now is a trial network. It's based on about 14 nodes. Each node has 3 to 4 Terragraph radios, and we're serving about 10 end users at the moment, and also feeding a Wi-Fi hotspot network within the tourist area. Based on that, we see the user experience have been pretty great. All the beta trials that we had done, and the beta users that are using the system, they're very happy with this with service. We're seeing speeds over 900 megs on most of the cases. Some users, we have done trials with equipment that's capable of over 1 gig, and we saw where was maybe 1.5 gigabits per second through the system. And remember, this is Terragraph trial equipment that is based on 802.11ad. It's not AY, so
yeah, so it's kind of prototype equipment in a way.
exactly with the old chipset. So we were pretty excited about this, seeing those speeds. So with the new chipset, we're possibly going to see easier, double than that. So we're pretty excited about that. And the use case we see for this, at least for us, we truly believe this technology will enable us to provide gigabit services to businesses, to residential areas. I know that, and we see it also as a complement to fiber, but on some instances, we can use it also to compete with fiber, because in some areas, at least financially for us, it doesn't make sense to deploy a second fiber network, but you can go in and deploy a gigabit wireless network and compete with the fiber contender on that area. So for us, it's a fixed wireless play, business and residential. We see it as a great tool for us to complement our current network.
That's great. And I guess, therefore, higher speeds means also higher revenue in some cases too. For
yeah, you. Basically, definitely.
Yeah. Thank you. Anthony, you're actually our other Brit. I think you're in Devon right now. So I kind of get interested in Cambium's perspective on why do you think Terragraph is a good fit for members of UKWISPA, for my audience and my members?
Okay, well, what we see Terragraph is really affordable gigabit wireless, right? It's enabling you to get gigabit wireless at the right price. There's going to be many solutions for gigabit wireless coming up, whether it's 5G, fixed wireless access, or even Wi-Fi 6 as well. That helps with this. But Terragraph is a very affordable way of doing this. For WISPs, it's another weapon in your arsenal to deploy wireless at high speed. For fiber operators, it will augment it will help. It will be something that will help extend fiber. You use it to bridge that gap between the POP to the customer, to spread the wireless around an industrial park, to do that last few hundred meters to even a kilometer. You can do this. And as AD said, you can actually link these together. This is the whole point of the mesh. You can link these together to do that fiber extension. So huge opportunity there. But then we talk about Gigabit Britain. Boris mentioned about the GBVS scheme. We already know GBVS allows you to have a wireless proportion within that solution. So it enables you to take the fiber and extend it into premises. And 60 gigahertz perfect for this. Then Gigabit Britain is then a further extension of this. We know there's going to be areas of Britain which cannot get fibre to every home. You can't pass every roadside. It's not going to be worthwhile. The money won't be there to actually do that. And this is where, by extending that fibre using 60 gigahertz, you're going to reach those homes. And there will be incentives by the UK government for people to do that. And this is where I see the WISPA members and operators being able to utilize that.
Yeah, thanks for that. I think I agree that there's a frustration really with current wireless technology that there aren't many compliant products that meet the gigabit specification as set out by DCMS. And it seems that every Terragraph deployment will meet those criteria very, very comfortably, which it creates a much bigger market for UKWISPA operators.
David, can I mention then on that, on compliancy, RDOF in the US with that's for rural broadband is already started, and they opened that up to wireless. It was going to be limited just to fibre, but they lobbied and they opened that up to wireless. And we have, and I'm sure many of the OEMs, we've been involved in trials in that to prove that gigabit wireless is capable, and go and also apply to the FCC in order to get those licenses. This technology will provide that gigabit access.
Yeah, thank you. So I'd like to stick with you just for one more moment, Anthony. Your Cambium has been in the fixed wireless market forever, since before there was a fixed wireless market probably, and but 60 gigahertz isn't where you've been for very long. I know people like Ciclu, for example, have been quite active in the 60 gigahertz space for a number of years. Yeah. Where do you see this fitting into your portfolio?
We started looking at 60 gig 10 years ago. We looked at WiGig, we looked at AD, and there wasn't a technology there worth, obviously Ciclu has made a great success of this, right? But for us, to do fixed wireless access, to do affordable access, point to multi-point, there wasn't really a solution that we felt was affordable or actually up to the job until we joined in with Terragraph. And at that point, with the advances in technology, TDMA, synchronization, the MAC, the PHY that has been put together in order to deliver this, that has given us a solution. It will enable high density deployments and cost effectively. Cambium really is looking for any solution that will help us in having this wireless fabric from Wi-Fi up to licensed unlicensed products, and this just fitted perfectly.
And presumably you've integrated this in terms of how your management platform, your own ecosystem within Cambium, so that if people are already used to using Cambium, then their transition into Terragraph will benefit from that in some way.
So as Mark mentioned in his presentation, obviously you have a Facebook network management system. However, Cambium does have our CN Maestro platform, and that's, of course, 60 gigahertz Terragraph will be put straight into that. CN Wave will be part of the Maestro. You'll be able to monitor that, your CN pilots, your Wi-Fi, your point-to-point links, all in a single pane of glass.
Yeah. And Adi, in Radwin, how do you see that? Similar?
Yes, absolutely. You're asking about...
Sorry, you're a little quiet.
Yep, sorry. Yeah, I mean, just like, let me take it from where Anthony put it. I think that, just like Cambium, Radwin had been serving fixed wireless access and serving urban, rural, suburban. I mean, all these areas are covered. Mid-band technologies are there, right? I mean, sub-6, no matter which sub-6 gigahertz can serve, take a fiber pop and then distribute connectivity. So there is variety of technologies. So why Terragraph? Simply because the demand for broadband is growing, the need for higher speeds, but not only that, you need now to deliver symmetric services more and more, right? And you need a much more powerful, high-capacity uplink than before. So you need much more broadband. You need much more bandwidth in order to do all that. And I think Terragraph has a unique value proposition from the reasons that were mentioned by Boris, Anthony, Gino, to do that, to take that fiber pop and now extend it much more effectively. It's a natural complementary component to a portfolio and a natural complementary component to a fixed wireless access user, any service provider, just like Gino had mentioned. I think the adoption, first of all, we see our customer base or our customers really looking forward to adding it to their portfolio and use it to connect more customers, upgrade the capacity to some users, connect more users, being able to address high capacity users, business users, compete with fiber in some areas, complement fiber in others. And indeed, I think what you asked maybe to comment on integration to a portfolio. The integration of the radio is obvious. I think the integration to the tools is obvious as well, but we do need to understand that Terragraph requires a much more accurate and precise planning, for example, because you're much more, you're in an urban area. You need to address buildings much more than you used to when you're working in mid-bands, for example. Things that Ciclo are used to now, Cambium and Radwin are getting into. So it's, I think for both Cambium and Radwin, we take the components, and obviously Ciclo, they've been there, take the new technologies delivered by Facebook, adding on top of it our own knowledge, and then also integrate them and upgrade our OSS tools, planning, management, installation tools to support millimeter wave technology, which needs enhanced capabilities that Facebook and us bring to the market.
Yeah, thank you. So, I mean, there's a clear picture there that, again, because the Terragraph vision was created some years ago, you've already been able to start the journey of embedding and embracing and sprinkling your own magic sauce onto the Terragraph platform. Mm-hmm. Boris, I'd like to turn to you first of all. We're excited by the idea. When do you think we'll see some product? Starting with you, Boris from Ciclo.
Oh, that's a great question. So 2 months ago, we've conducted 4 trials with the local operators here in the United States. We've showed 3.8 gigabit per second per sector capacity. In August, we are going to do our first deployment in London, in UK, for it will be a sizable network, part of the 5G neutral host. And basically, we are accepting orders. We are working with the customers on planning the trials, and pretty much everything is available.
So first, if I wanted to buy some equipment in the UK to do a deployment, and I wanted it with a Ciclo badge on, when am I talking?
So next month we'll start delivering.
Okay, that's great. And how about Cambium, Anthony?
Cambium is actually involved in a number of trials around the world as well. So we've been doing mesh trials, we've been doing point-to multi-point trials, small cell backhaul as well. So so everything's going well, and we expect to be going general availability in Q4.
So during this calendar year, we would expect. And Adi, for Radwin?
Yeah, we're, I believe, all in more or less in the same schedule, and yeah, we're now undergoing trials. And basically, the purpose of the trials, and we will be GA in October. Basically, what I think we're focused on right now is the product is there, the mesh is there, things are going very well. We're seeing the same performance that Boris mentioned, 3.9 gigabits per second. We're all using the same chip, so we expect to see the same performance. The thing is, where the focus is to develop really the processes, the tools to enable fast deployment, to ramp up the deployment. We're all in there to enable large-scale Terragraph deployment. So what we're doing right now on our trials with our selective pipeline that partner with us on these trials is to develop with them, with the service providers that we work with, really the operational approach. What do you do? How do you plan it? What do you leave for the field team? What do you do ahead when you're in the office? What do you do in case what you thought is available is suddenly not available in the field? I mean, you were thinking you have a line of sight somewhere. What do you do with that? How do you align better? How do you report back the results of the trials? Because we believe that providing to the customers a good set of tools would enable them to not just do trials, but to ramp up the business much faster and on their own. So
not a matter of when you can get the equipment delivered through the distributors. It's when can somebody actually build a solution that works, that's properly planned, properly managed, supportable and maintainable. I think that's a really important point, that not rushing it as a piece of hardware, but introducing it to the market as a solution. Thank you for that. Gino, returning to you again, how do you see the economics of this compared with other technologies? You mentioned that you do some work with fiber. You've obviously got a track record with fixed wireless. So do you see this as being an alternative? Are you thinking, well, actually, we did some work with fiber, now we're not going to bother with that? Or are you seeing this in some way complementary?
I think it's complementary. There are some instances where the fiber will make sense, other instances where Terragraph makes sense for us. It all depends on the end pricing that the vendors here will provide to us. So I don't have any final numbers from any of them, but from preliminary data that we have received, it seems that it's going to be a very interesting play for most of the, or I must say all the wireless providers, that they will be enabled to provide gigabit services using this technology. So pretty exciting times.
Yeah, cool. Thank you. I'd like to just explore a little bit more about mesh. We're starting to run short on time, but there's a few questions that have come in from our audience in relation to range, how far a signal can travel, and I think it's quite important to really consider that, and how mesh plays a role in that. Adi, if you don't mind, just kind of why do you think, what is the importance of mesh?
So I think mesh has a lot of value, especially millimeter wave. I'll try to classify it into three groups. One is the physical barriers of a millimeter wave, short range, line of sight. When you have mesh, you can go around obstacles and you can extend the range by cascading units, right? That's the whole idea about the mesh. So you don't need to be that close to fiber pop. You can extend the range by meshing your different nodes of the mesh. So that's one component. Yeah.
And can I press you on that in a practical sense? So let's say I've got a village, or I've got a town, or I've got a city, and I've got fiber at a point. I can bring in a 10 gig backhaul or whatever I can bring in.
Yes.
Realistically, how far can I push that mesh?
You can push it as far as you want. And that's the whole idea. One link, let me clarify, of let's say 4 gigabit, around 4 gigabit, will go probably 100 meters. Right, that's physics, and that's the EIRP allowed, and that's what more or less all of us can deliver. I mean, I'm just taking a rule of thumb here. If you reduce your capacity, let's say by half, you can extend the range by half, more or less, or by 50%. Doesn't matter, but it's a few hundreds of meters. However, since the mesh allows you to cascade units and actually connect a distribution node to a distribution node to a distribution node, and further on, you can extend it as far as you want, considering now the latency that you're bringing in. By the way, yep, it's a very low latency system, so you can cascade as many. And maybe one more point, you don't connect the mesh to just one fiber pop, and that's a very huge advantage of the mesh. You can connect that mesh that I just described to as many fiber pops as you want. So even if that's all connected to one fiber of 10 gigabit, you're actually feeding it from different geographical locations. So by doing traffic balancing, any location in that mesh can basically get the highest capacity, and you don't create any bottlenecks in the capacity flow inside the mesh. So realistically, what we see in planning Terragraph networks, or Terragraph, I call it sub-networks, feeding from a fiber pop and extending further out, we see it running for a few kilometers, right? By connecting all those nodes together and creating a whole area of a Terragraph mesh.
And on a similar theme, Anthony, if I may, so if I bring some fiber to a point, I build a mesh. The other characteristic of mesh is it's kind of self-backhauling, isn't it? So would you say it's realistic to be able to go to a cluster of properties, spread around a mesh, and then take fiber from there and move, and then run fiber from that as a backhaul to a different destination, and then build another mesh? In other words, the hybrid of jumping in and out between fiber and wireless, presuming you've got a good backhaul at each end. Would you say that's
absolutely? The sort of micropop approach of going into a cluster, sort of moving out from that point and then moving on to the next cluster is more than doable. And the equipment that we have is capable of doing that, linking up either multiple radios or multiple Ethernet or POP points. Yeah. But yes, it's more capable of doing that.
And sorry.
Yeah, and adding, if I may, Boris, just looking at the commercial model around this, you made the point about this being gigabit Britain compatible. This is going to help the gigabit. Excuse me, put my teeth back in. Easy for me to say. The gigabit Britain story, but the operating costs. We need power. We need maybe access to maybe street furniture or buildings or whatever it would be. How do you see the relative cost of operating Terragraph equipment compared with, say, potentially the operating cost of operating fiber and paying fiber tax, which has been getting suspended, but it is coming?
Yeah, so there is no silver bullet in connectivity. Okay, there are advantages and disadvantages. You take fiber, you take sub-6, you take millimeter wave. Each and every technology has advantages and disadvantages. Definitely, the cost of building a wireless network is significantly low. Now, it depends what type of fiber, what type of wireless technology you compare it to. Now, I think that the main benefit of the Terragraph solution, and in particular millimeter wave, it behaves differently from other wireless technologies. It means that if in sub-6, for example, you put a tower and then you spread the signal over a distance of 10 kilometers, 20 kilometers, and you estimate the performance, there is no way to really calculate. You don't know what vegetation is. You don't know how the propagation will be. You don't know the interferences. But the installation is pretty simple. You just put it there and you spread it all over. In millimeter wave, the key is planning. When you do the planning is hard, okay? But when you accomplish that, you'll be able to deliver gigabit no matter what. It's not, if the network is engineered right, it is not subject to rain, it's not subject to anything else. Now, in order to simplify this planning exercise, we've seen Facebook, they have some planning capabilities. We see ID and Anthony are talking about their planning capabilities, and we have those planning capabilities, and this is what drives the cost really down. It also enables, we have the tools that also enable to take advantage of this technology to service providers that don't have wireless experience. Okay, this is one of the major roadblocks. For example, if you take a wireline carrier that has experience with DSL and has experience with fiber, bringing this wireless knowledge, bringing this wireless expertise, it will take them a while. So using our tools, using our automated planning capabilities, they can do it like within a couple of minutes, and it is really easy. It is very hard to answer about the exact operating costs, but definitely the spectrum is free, as you've mentioned. It is licensed exempt, so there is no operation cost in the spectrum part, comparing, for example, to other technologies like 5G. The spectrum is very expensive. Once it is up there, the equipment is usually very low power. For example, the thermal unit or one sector consumes less than 10 watts. So the cost of the power is really negligible. And the upfront investment is as I've mentioned, is well below 100 pounds per home pass, which is significantly lower than fiber. Now, each and every case should be considered, in particular, should be planned. And this is why we all formed this ecosystem and why we are partnering together to enable that.
Thank you. We're going to draw to a close shortly, but before we do so, I'd like to return to Mark from Facebook, if I may. Mark, you've been and the team have been working on this initiative now for some time, and it's clear that you've built an ecosystem. You've not designed a technology or a protocol. You've taken that much further. You've developed planning systems. You've encouraged Qualcomm, in this case, to bring in a high-speed, low-cost chip. You've got OEM vendors, and we've got the first 3 of those with product to market now, and I expect that we'll see more in the future. So, is your work done? Is that it now? Is this the end for Facebook, or if not, what's next?
So great question, and thanks everyone for participating today. I think everyone realizes now you could do Terragraph to deliver broadband to homes and businesses. There's a lot of other use cases that are coming in, and we're hearing about train stations, airports, any place you have a need for high capacity. It can fit campuses, military bases, and so forth. And so our contribution, as we kind of talked about up front, will continue to be most likely within standards, within ecosystem development, with regulatory unblocking, as we call it, in different areas, so that more license exempt spectrum is available. And that's where we see our role in the ecosystem going forward. We're going to continue to contribute as we have been on some of the technology development, but once this bird has sort of left the nest, as it were, from a technology standpoint, it can grow and fly on its own. And we're so excited to see so much great work happening from so many different OEMs who are contributing to this, as well as service providers who are coming to us with things we hadn't thought of about how they'd like to use Terragraph. So it's the beginning, a pretty exciting beginning, and hopefully we brought enough together to make it work. So we'll continue to be there contributing, but we really see the ecosystem doing, benefiting from this and contributing to it going forward.
Thanks, Mark. Yeah, it sounds like the end of the beginning, really, and now the fun begins. So it's going to be a really exciting time. So we've got a few more questions that came in from the audience, which I'm afraid we won't have time to answer here and now. But we will put out a response to the attendees, and we'll answer as many of these questions as we possibly can. I'd like to thank our amazing panel for spending the time with us, for most of you this morning, from as far away as California and Puerto Rico. So thank you all for taking the time to share with us your experiences so far and your plans for the future. We're particularly excited in UKWISPA. We're going to fully support this. We'll be continuing to work with government, with Ofcom, and with DCMS to ensure a smooth ride for anybody who wants to do any voucher applications as soon as this kit becomes available. And we will be ensuring that there is as much visibility of this technology as possible within the F20 program, which is the £5 billion funding for Gigabit Britain that commences next year. And we're already seeing some positive feedback from DCMS and their interest in it. So it absolutely puts fixed wireless back on the radar. So thank you, and I'm sure we'll be speaking to everybody again on it. So it's just for me to wrap up now. Thank you everybody for joining us on this special event. I really appreciate the time from all of our panelists, from Gino, from Adi, from Boris, Mark, Niraj. I'm afraid we didn't give you a great deal of time to talk today, but thank you for joining us from Facebook too, and Anthony from Cambium. We wish you all a great day. Thank you very much indeed. Everybody, please keep safe, and we look forward to seeing the history unfold in relation to this technology. So thank you all.